The next set of problems, well, here they're starting with a base of e, no problem. I look at an equation, I see an exponential in it. This is called an exponential equation. So I would isolate the exponential by itself. This is only me. I see a fraction, I think of an LCD. LCD is 6. Since this is an equation, I could ignore that denominator, and I'm looking at 24 plus 6e to the 3. No, okay, I don't like that. I want it to look pretty. 24 plus 6e to the 3 minus x plus 6 times 1 is 6, 6 times 10 is 60. Subtract 6 from both sides. Oh, before that, combine those. 30 plus 6e to the 3 minus x equals 60. Subtract 60 from both sides. Divide by 6 both sides. And that's a 5. And since there's no way I could make the bases the same, I'm going to log both sides. Log base e on the left will cancel that. And log base e on the right. Of course, that's ln of 5. And divide by a negative 3. And that would be ln of 5 divided by negative 3. If I plug that in my calculator, what do I get? What is ln of 5 divided by negative 3? Negative 0.54. The next problem, again, this is an exponential equation. What do you do with this? You isolate the name by itself. If it is a radical, log, absolute value, trig, you name it. So subtract 5 from both sides. 8 minus 5 is a 3. And the 4 is there, divide by 4 both sides. So I have the exponential on one side, everything else on the other side. That's the goal every time. Now, if I can't make the bases the same, there's no way I could make e into any, e is an irrational. So I know I'm going to use the definition. The definition was what we spent time on the last homework. Go from log form to exponential, meaning log both sides. What base should I use? Again, I'm going to write it down in case you've forgotten. To eliminate, I need the base to match the base of the exponential. You could simply write that and say 7x minus 8 equal natural log of 3/4. Add 8 to both sides. And divide by 7. That's the exact answer. And if I want to approximate that to the decimal places, I'll get my calculator out, and we would take parentheses natural log of 3/4 plus 8 divided by 7. 1.10. 1.10. And I'm going to do another one. Again, these will never end. I'm glancing at this. I need to isolate one of these by itself, but we have a problem. There's 2 of them. Well, get them all on one side, everything else. So get them both on one side. See if you can combine them somehow. Well, I am aware there's no way I could combine those in any way. So that's when I look at this, say, okay, but do you notice that this is the square of that? So if I write this as 2 times, if I write this as 5 to the 4x, if you multiply those powers, don't you get that? If I let y equal 5 to the 4x, then if you square both sides, if you square this side and square this side, wouldn't this be y squared equal 5 to the 8x? That would be 2y squared minus y minus 3 equals 0. Wait a minute, I can factor this. I'm a master in factoring, right? I'm taking college algebra, not beginning, not intermediate, so I could definitely factor this. There it is. So that means y is either 3/2 or y is -1. Well, substitute the exponential back. Wouldn't that say 5 to the 4x equal 3/2 or 5 to the 4x equal -1? An exponential can never ever be negative. Here, wouldn't you say I'm going to transform that to exponential form, to log form, since I can't make this a base of 5? So if you log with base 5 both sides, wouldn't 4x equal log base 5 of 3/2? And what would x equal? Isn't x log base 5 of 3/2 divided by 4? And how do you find that? Change the base formula. Isn't that natural log of 3/2 divided by natural log of 5 divided by 4? And you could input it in the calculator that way, as you see it. Watch. I could say take natural log of 3/2 divided by natural log of 5 divided by 4. One shot. 0.06. There it is. Alright. The next set of problems is dealing with a log. Well, hey, how do you solve any problem? Well, this is a log equation. It's an equation that has a log in it. You solve any equation by isolating the log by itself. So, if I want to isolate the log by itself, subtract 12 from both sides. Is that 13? Oh no, that's 9. Same thing, right? Okay, and now what? Well, there's no way I could write that as a log. I could, but we're not going to go there. So I'm going to transform this from log form to exponential form. Do you remember? Since the base of the log is an e, I'm going to make that the base to both sides. Those will undo each other. I'm left with x plus 5 cubed equaling e to the 9. Now what? Now I'm looking at a cubic. Well, I know how to solve a cubic. Cube root both sides. And you could leave it like that, or you could write that as e to the 3rd power if you want. Because this is e to the 9 raised to the 1/3. But if you leave it as the cube root of e to the 9, that's accepted. And what's x? -5 plus e to the 3rd. And if you had -5 plus the cube root of e to the 9, that's accepted as well. That's not a problem. Alright, how about this problem? This is a log equation. You isolate the log by itself. That's how you solve any equation in math. And now you're going to make this a power of e, because there's no way you could use logs. Well, x minus 2 squared is going to equal e to the 27. How do you solve a square root? You square root both sides. I give it away. X minus 2 equal plus or minus the square root of e to the 27. Add 2 to both sides. Now we have a problem. It's not really a problem. Anytime I start the problem with a log, I want to make sure that my answer will ensure that this is bigger than 0. Since you're squaring that, you're safe. Kind of like a radical. When you start the problem with a radical, you have to make sure that the answer will always make that positive. Okay, and how does that work? Again, a problem. Add 2 to both sides. That's a 10. Well, if I want to get rid of this, then I'm going to make this, right? I want those to match, if you remember. And I have 1 minus x to the 5th equal 3 to the 10th. Take the 5th root of both sides. Here I could simplify that. 3 to the 10th raised to the 1/5. Isn't that 3 squared, which is a 9. So 1 minus x equal a 9. Swap those. X would be a 10. If x equal, oh, not 10, I'm sorry. X would be I misspoke. X would be a negative 8. If I replace x by a negative 8, 1 minus a negative 8 is a positive. That's allowed. So it checks. That's how you check it. You really don't have to do a lot of work. Most of the time, visually will do. I have 3 more. So we're spending all of this time mastering how to solve log equation, radical equations, so when the time comes, you'll know how to do them. How about that problem? It's a log equation. What do? You isolate the log by itself. You know what? Just did too many of those. Okay. So let's look at this problem here. We'd like to solve. And I noticed we have 2 logs and a number. We get logs on one side, everything else on the other side. We already did. For me to use the definition, there should be a single log. For me to use this, it should be a single log on one side, everything else on the other side. I have 2 logs. So I'm looking, those 3 are almost the same. Let me tackle number 72 first. So when I glance at that, I say, okay, well, I have 2 logs. 2 logs with a plus in between. If the coefficients are 1, I know how to combine into a single log. And how does that work? You would write whatever this is times whatever this is, remember? So that's x plus 2 times x plus 4. I'm not solving, I'm not working anything out, I'm just combining 2 logs into 1. And now I could say this is the log base 2. This is going to be x squared plus 6x plus 8 equal f3. Well, either way, I'm going to have to go from log form to exponential form. I need to make both sides a power for a base of 2 because that's always the case. So this says x squared plus 6x plus 8. 2 to the third is 8. What do you know? That's a polynomial. Isolate the polynomial by itself. Factor. X would be a 0 or a negative 6. Now I have to check. If I let x equal 0 and I put 0 there, 0 plus 2 is positive, 0 plus 6 is positive. That's good. But if I put a negative 6 there, isn't negative 6 plus 2 negative 4? That's not allowed. So 0 is the only value that will work for this problem. I get to number 7. You say, okay, well, we have a log. They already put the logs on one side for us. They're really nice. But there's a small problem. I know how to deal with a minus. I can't seem to deal with that too. Well, the third law allows me to make that a 1, and that's a must. And 2 logs with a minus in between, I know how to deal with that. I would write that as a single log of the subtraction becomes division. Do you remember that? And that's a 2. And now I'm going to make those powers. And once you get the hang of this, you really don't have to show that step anymore. You could jump straight to this. That's a 9. I see a fraction. Cross multiply or clear the fraction somehow. This is a polynomial. I know how to deal with polynomials of any type. And is this factor? Let me see. If I'm going for 2 factors of, let me just make sure the algebra is right. That's right. 3 squared is 9. That's 9x minus 36. Okay. 36 has factors 9 and 4. Subtract. They have to subtract, right? That doesn't work. 12 and 3 will work. If I take x minus 12 and an x plus 3. And if that wouldn't have worked, I would use quadratic formula or contain the square. So we're saying x is either 12 or a negative 3. And then when you do that, you say, well, wait a minute. I need to check my answers. 12 in there, make it positive. 12 in there, make it positive. But a negative 3 right there is not allowed. You know what? I'm going to enlarge this just a bit more and fit those under, because I'm not sure how long the last problem is going to take, so that we have extra space if we need to. And the last problem, number 76, same deal. I see two logs with a minus in between. I know the drill. This is going to be division, but I need for that to be a positive one. It's not. I know the third law of logs allow me to move powers, and that's what makes logs so unique. Not only that, but that's one of the main. So two logs with a negative I could write as a single log of x squared, and the negative turns into division. And if I make those powers a base 2, that's going to make this x squared over x plus 5 equal 2 to the 4th. Hopefully you're that comfortable with that. That is 16. Cross multiply, or clear the fractions, 16x plus 80. And x squared plus 16x, x squared minus 16 minus 8. I shouldn't rush. So now what? I'm trying to factor this, two factors of 80 that subtract to give you 16, 4 and 8. 20 and 4. X minus 20 and x plus 4 would equal 0. So x would be a 20 or a negative 4. And again, I have to check the very original, you guys. 20 in there is fine. 20 plus 5 is positive. Negative 4 in there will make that the log of a negative value. That's not allowed. So I check my answer anytime I start a problem with an even index radical, a fraction in which the denominator could be 0, or a log. Now we want to look at a couple of more problems. If you recall, the formula was A equal P into 1 plus R over M raised to the n. Or if it's continuous, there it is. Well, suppose $11,400 is invested. That's P. And a monthly compounded monthly, that means that's a 12. That's a 12. At 4.98, 0.0498. So here we're reading A equal $11,400, monthly M equal at 12. We're reading the interest rate is 4.98%, which is 0.049. And approximate how long would it take for the balance, I'm sorry, did I say PA? I meant P. For the balance to reach $25,650. So based on what I see, there's a 1 sitting there, T is right there, and A is simply $25,650. So A is right there, P is right there, right, to reach, so it takes time. You're looking for time, of course. And monthly compound, that tells me that M is 12, that's this, and this, right? I'm putting everything in colors, hopefully so you can see it. And the interest rate is right there, it's right there, and it's right there. The only thing left is T. Well, what kind of an equation is that? That's an exponential equation. How do you solve that? You isolate the exponential by itself, but it's already isolated by itself. Actually, it's not. I need to get rid of this to get the exponential by itself. So I have 25,650 divided by 11,400 equaling, and let me see if that could add up to a fixed value that will be good. 1 plus 0.0498 divided by 12. Okay, what is it didn't like? 1 plus 0.0498 divided by 12. 1.00415. 1.00415. Do you see that this is an exponential equation? We just solved exponential equations. What are you going to do? You're going to log both sides. What base should you use? Didn't we agree the base of the exponential? So if I read this correctly, this is reading a log with a base of 1.00415 of 25,650 divided by 11,400 equals 12t. How do you get t by itself? Don't you divide both sides by 12? And you'll say t equal log of 25,650 divided by 11,400 base 1.00415 divided by 12. How am I going to figure that one out? I'm going to get my calculator out, and guess what? Log of 1.0045 with a base of this quantity. Isn't that natural log of 25,650 divided by 11,400 divided by natural log of 1.0? What is that called? That's called change of base formula. Change of base. So when I want to plug that in my calculator, I'm going to take parentheses as I see it. Natural log of 25,650 divided by 11,400, close parentheses, divided by natural log of 1.00415 divided by 12. 16.32 years. 16.32 years. And I have one more to go. And to reinforce this idea, I want to do one more problem. Suppose $2,300 is invested. That's P. $23,300 compounded daily. That means M is 365 days. Interest rate is 5.28%. Approximately how long, in how many years, will you have a total of 46,600? So the formula, of course, is A equal P into 1 plus R over M raised to the MT. So here we want double the amount. One plus R was 0.0528, M was 365, and 365T. Again, I'm going to color code those really. Investment is right there. Amount is right there. Compounded daily, that tells you it's 365. That goes in two places. And the interest rate obviously is right there. Now I'm going to do the same. It doesn't matter what kind of word problem is it. You're going to come up with an equation, obviously, in math. This is an exponential equation. You isolate the name by itself. You divide both sides by 23,300. Well, this becomes a 2 equal. And you try to figure out if this is possible in a calculator. That saves me a lot of work. So if I take 1 plus 0.0528 divided by 365, it's a big number. Out of mind, I'm going to go with 1.3 zeros. $144,658. $144,658. Now you do notice that this is saved on my calculator in answer, right? If I click answer, it's that number raised to the 365t. Now what? I'm gonna take the log of both sides. What base should I use? Shouldn't I use this base for me to eliminate the logs? Again, this is from the previous section, right? And here, those will undo each other. So I'm looking at log base 1.000144658 of 2 equaling 365t. So divide by 365, and there it is. And hopefully you are using your calculator to practice this. You're going to input that as a natural log of 2 divided by natural log of 1.000144658 divided by 365. But I already know this is stored in my answer, so I'm going to put natural log of 2 divided by natural log of answer, so I don't have to write all of that mess, divided by 365, one shot, 13.13 years. It's going to take 13.13 years. And the homework is listed right there. And that concludes this section.